Hi everyone, now we are going to discuss about one of the major difference between OLTP and OLAP, that is the normalization and denormalization. Normalization, denormalization. I said one thing is that in the OLTP the tables will be normalized form, in the OLAP the tables will be little bit denormalization, denormalized OLTP, OLAP. Okay, so what is meant by normalization? So in the initial time when the first develop the database, the data is not stored properly. Like you'll have the ID. Let's take I have the sales table. The sales table will have the ID, like it's nothing but the sales ID. It will have the customer ID, customer name, okay, and the something like whatever the quantity it is, or some part number and the quantity and amount. This is what they have. Sales ID 101, 102, 103. Customer is C1, C2, C1. Customer name is C1 ABC, C2 ABC. This is C1 ABC. Part number is 1, P1. You also, let's take all the part numbers. Quantity is 2, 5, 7. Amount is 20, 50, 70. Okay, like this I might have like thousands or millions of records here. So the issue they faced here is, let's assume let's assume they want to update the customer name got changed, and now they want to, if they want to update the customer name, they have to update all the records in this table. At the same time you might have one more table with the customer table, okay, or else I'll not take the customer, I'll say this is a sales, I'll have one more table called transactions, or best example I'll have invoices, okay. This will have the invoice ID, invoice ID, and then which in you who paid, which customer paid that invoice, and customer name. Like that I'll have the name stored in a separate table too, okay. So I have the invoice ID I1, customer ID is C1, he paid $20. Next I have the invoice ID 2, customer 2, he paid $50. Then I have the invoice ID 3, customer 1, he paid, sorry, this is a customer name, right? Sorry guys, I have given the wrong data. Customer name and the amount. So customer name is C1 ABC and the amount is 20. I got the invoice 2. This is a C2. It is a C1 C2 ABC and it is 50. I got the customer invoice I3, customer C1, C1 ABC and 70. Now see, if I want to update the customer name, I have to update in two tables. Let's assume the customer name got changed, so I have to update in two tables. One is in the sales table, other is in the invoice table. Here you might see an issue, and this is only as per your knowledge you are having in two tables. There may be some other tables where the customer name might be there. Okay, so you have to update all the tables. Let's assume the user updated in the sales table, but he might have forgot to update in the invoice table. Then what will happen? When other one comes, he doesn't know which one is the latest one. Let's assume the user update the customer name C1 to C1, C2 to C2, C1 again, this one, like this. Okay, this is whatever the customer ID is there, he updated the same customer ID as a customer name in the sales table. He forgot to update in the invoice. After a few days, I goes there, and when I see the data, I don't know which one is the latest, because here I have the customer name as C1, here I have the customer name as C1 ABC. I don't know which one is the latest. So because of this, the data is not consistency. The data is wrong. No one knows which one is the correct data. The one who had updated, he knows that one. Apart from other, doesn't have any idea. Okay, and like this, there might be many issues pending to that. So that's the reason what they do. They make the data consistency. They make the data consistent. How do they make the data consistent means they'll create a tables in such a way that it will be easy for them to maintain the data. For that purpose, what they do is that for the same, I'll minimize this. I want to have all the columns. stored. Yeah, customer ID, customer name, amount. I got it. I'll move this up. So now for this table, what I'll do first, I'll create a table called customer. I'll create a table customer, and the customer table will have the customer ID, customer name. So it will have the C1, C2. C1 name is C1 ABC. We'll take with the first one, C2 ABC. Now what will happen in the sales table? When I see the sales table will have the sales ID, it will have the customer ID, it will have the part number, it will have the quantity and amount. Same with the invoices table too. Invoices, you will have the invoice ID. I am writing a shortcut IID. You will have the customer ID and amount. That's it. So since if someone wants to see the customer name, they will join the customer ID of this table with the customer table and get the customer name. And if I want to update the customer name, I'll just update the customer table, customer name in the customer table to C1, 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 C1. That's what I do here. Okay, C1, I'll update it to C1 only. When I do that, it is the data got updated in only one table. So it is nothing but whatever the information related to customer will be stored only in this information in this table. That's it. Okay, if I want to update, I will update only this table, not the other table. Which if I want to update the customer information, I will update. If I want to update the sales information, I will update only in the sales table. Like, because after breaking, it made me easy for me to update, and the data also is in the consistent, it's the correct state. If other one comes, you will be seeing only one data, you will not see the old data, because the customer has the latest data. That's it. There is no need for him to confuse also. If someone wants to update, they will only come and update in the customer table. Okay, like that. This is only a simple example. Like that, you'll have many you'll have many like many columns which will store the data related to multiple stuff. Like here, this columns has information related to customer. You might also have the part number, part description. Okay, and part size. That all you might have it here in a single table. But I can create one more table with the part number with all the information, and I can have that part number used here. Okay, so breaking of tables is nothing but the normalization. Breaking of tables is nothing but the normalization. What is the breaking means? I have one table here which has a sales ID and customer information. I have the other table which has a sales ID and customer information. So same customer information is stored in two tables. That's the reason I have separated the customer information to a separate table. So now I have three tables. Okay, breaking nothing but for every information you will have a separate table. That's it. That is not called nothing but the normalization. Okay, so in the normalization process, if you want to get any information, you have to join multiple tables. You have to join, if you want to get any customer information, you have to join the customer ID with the customer in the customer table and then get the customer name, like that. Okay, that is nothing but the normalization. So you have multiple normalization forms. So in order for the OLTP to be normalized, you should have at least the third normal form. Okay, third normal form. You'll get more info by searching Google, because if I explain the normalization, it is going to take a lot of time. Okay, so please search in Google. You'll get more information of different types of normalization forms we have. Okay, but it should have the OLTP means should have the minimum third normal form. Then what is the OLAP? In OLAP, what we do? So here in the OLTP is nothing but you are breaking the tables. Let's take, you have originally you might have two tables, but when you break it, you might have five tables. That is the OLTP. In a OLAP, what you do? Generally, why you use OLAP? OLAP is used for the users to analyze the data. Let's assume I want to analyze the data on customer names. So then what I'll do, I'll join the sales table with the customer table and get it. Okay. If I join more number of tables, as the number of joins get increased, for me it is going to take more time and the performance will be very less. You know, if I want to get information from one table, I can get it. But if I want to get information from multiple tables, let's assume I have joined table 1 and table 2. Okay, it is good. If I join table 3, table 4, table 5, means it is going to affect my performance. As the number of joins get increased, it is going to affect my performance. Okay, that's the reason what I do in the OLAP is I'll do a little bit of normalization. Let's take you are divided 2 into 5 tables. Now what I am going to do, I am going to combine some tables and make it into 4 tables. That's what I am going to do here in the denormalization process. Not exactly like I'm not going to convert this 5 into 2 tables, but I am going to little bit denormalization, nothing but reverse to normalization. In normalization, you are going to break the tables. In denormalization, you are going to combine the tables, but not to the complete, not making from 5 to 2 tables, but you'll just do a little denormalization. That's it. Okay, that's nothing but the denormalization. And then now we are going to concentrate more on the other stuff. So this is the normalization and denormalization that is related to OLTP and OLAP. And after this, I am going to cover more about the OLAP process. OLAP, as I said, there are two things. One is relational and multidimensional. That one I am going to cover in next video.